Hello everyone, we are students from Gyeongnam Science High School in Korea. Today we will introduce what we have done so far for our research. The topic of our research was the effect of a cooling fog system utilizing recycled air conditioner condensate. Our research consists of two main objectives. First, we wanted to analyze the cooling effect of the fog system based on spraying duration, nozzle size, and spraying method. We thought this would help identify the most effective combination for temperature reduction. Second, we wanted to optimize the layout of the cooling fog system to enhance its overall cooling performance around buildings. This includes find how fog units should be arranged to maximize cooling efficiency while minimizing resource use. Through these two objectives, we aimed to connect experimental research with practical urban design solutions. We conduct two sets of experiments on our school campus. The cooling fog system was installed between trees spaced 8 meters apart with 10 nozzles arranged in a straight line at 0.5 meter intervals. We used a thermal camera to measure the temperatures of the experimental area before and after each spray.
Two independent variables were tested. First, training interval 0.5, 1 and 2 minutes on-off cycles. Second, nozzle size 0.2, 0.6 and 0.1 millimeters. This setup allowed us to compare cooling performance under different operating conditions. First, we tested the effect of spraying intervals using a 0.1 millimeter nozzle. Experiments were conducted on both a paved walkway and a grass surface. The 30-second on-off cycle was repeated 4 times. The 1-minute cycle was repeated twice, and the 2-minute cycle was conducted once. Based on our data, shorter on-off intervals produced a stronger cooling effect. The 0.5-minute interval resulted in the largest temperature decrease, especially on the grass surface. In this experiment, we compared the cooling effects of 3 different nozzle sizes: 0.2 mm, 0.6 mm, and 0.1 mm, by spraying for 3 minutes on both grass and road surface. The research showed that the 1.0 mm nozzle achieved the greatest temperature reduction among all conditions. We repeated this type of experiment 3 times.
In our experiment, we mainly focused on 2 factors: nozzle size and spraying interval. First, regarding the nozzle size, the 1.0 mm nozzle showed the greatest cooling effect. Second, when comparing spraying intervals, the 30-second on and 30-second off cycle provided the most stable cooling performance. The 2-minute interval produced a sharp temperature drop at first, but the temperature quickly rose again after spraying stopped. In contrast, the shorter interval maintained continuous evaporation. As a result, the 30-second cycle achieved both effective cooling and long-term stability. In this study, cooling fog units were installed along the building's exterior wall. Each unit was assumed to create a cooling effect within a circular area of 2 meters in radius around each nozzle. To determine the optimal configuration, we developed a Python program that calculates the maximum area affected by the cooling fog and identifies the arrangement of fog units that achieve this maximum coverage. Through this approach, we aim to enhance the overall cooling performance and efficiency of the system by optimizing both the number and placement of the cooling fog units. We estimated condensate using the dry air mass flow and the change in humidity ratio. Under 34.7 degrees Celsius and 75% humidity, and 0.6366 cubic meters per second of airflow. The predicted condensate production is about 40.7 liters per hour. This matches our measurement and show that one air conditioner can supply about 1.7 cooling fork nozzles using condensate alone. Next, I would like to introduce our future work. First, we plan to optimize the overlapping fork zones to achieve maximum cooling efficiency while minimizing resource consumption. By refining the layout and control of the fork nozzle, we aim to enhance the cooling effect without increasing water usage and energy demand. Second, we intend to conduct further research on the collection, purification, and storage of air conditioner condensate. This will contribute to the sustainable operation of the cooling fork system by ensuring a reliable and eco-friendly water source. Through this effect, we hope to establish a more efficient and environmentally sustainable cooling system. Thank you. Why?